All right, so, oh, and in all reality, we're basically having a video for, he's recording the recording, odd. But anyway, because Lila's not Lila, Lily's not here, and who else? Luke, Maddie. So those of you that didn't show up today, shame on you, but here we go. Okay, yeah. Scientists conducted a 9-week experiment on plants A and B, whatever, determined some fertilizer, whatever. Scientists found that plant A, its height is this function. Sorry about the line break. Scientists found that the height of plant B, H of B, is this function. Our domain is from 0 to 9, what is this, weeks? Yeah, 0 to 9 weeks. Their first question literally just says, when are these two things equal to each other? You were just supposed to set them equal to each other. This is a calculator test. You don't get any rewards for doing a bunch of algebra, so you just let the calculator tell you exactly what you were supposed to do. Sine of 2t plus 6 plus 9t plus 27 equals 8t plus 32. Allow me to show you what happened when I tried to do that. First of all, do not ever graph trig in degrees. Make sure you are in radians. I am. Y equals. Let me clear that. All right. Sine of 2x. I know that's a t. You have to use the variable button on your graphing calculators. Okay, sine of 2x plus 6, and then plus 9x plus 27, and we're setting that equal to 8x plus 32. All right, domain is from 0 to 9. So on your window, look, I still have 0 to 9 set up. Isn't that nice? The scale, I just went by ones. Now, when I just had from, I think I went from 0 to 20 on my y's at first, or something like that, 0 to 25, I got an image I didn't like. Actually, you know what? Let me go ahead and show you. Let's see. This thing's y-intercept is 32, and then it goes up at a slope of 8, right? So, I don't know. Let's take it 0 to 50. Now, that didn't work. Where's the other line? There. Okay, so my y value is clearly not high enough, are they? So window, all right, 50, no bueno. Let's try 100. Immediately, this line should be giving you a little bit of anxiety because you can see it's wavy, but you really can't see how many times those two lines crossed each other, can you? As it turns out, they crossed each other 3 times. But you see, I didn't know that. And I tried to zoom in by changing the window, and that's why you saw that window be smaller. And I tried to get really close to it to see them separate, and it just wouldn't work. They always looked like that. So did I panic? No. I did a little bit of algebra. I brought it all to one side, set it equal to 0, and then I looked where it crossed the x-axis. So subtract 8t, subtract 32, and what you get is a standard trig equation plus t minus 5 equals 0. So we'll just clear that one, get rid of that, and then minus 5. Again from 0 to 9, but this trig function, its amplitude is 1. Okay? So I don't need to go all the way up to 100 anymore. And we can't have a negative height. So, I don't know. What's a good number? 15? 10? All right. I don't know. I'm just guessing. I don't remember. Oh, you know what? I forgot to type y equals 0. Also, since because I want to do second trace intersect, I like that command. So I'm having the second line be the x-axis at y equals 0. I have to have, I forgot, this no longer models height, so I do have to have negative numbers. Okay, there. Now let's see what happens. 1, 2, 3 intersections. Now you can see there's 3. Okay, so second trace intersect is number 5. Yes, yes, and then there is your first answer at 4.01. Second trace 5. Yes, yes, scroll to the right, get the next one at 4.7. And then the last one, darn near close to 5 there, or 6, or whatever that is. Second trace, 5, yes, yes, scroll. And then hit enter one last time to get 5.88. There you go. It's 3 sig figs. So, for some reason, the answer on this question was worth 2 marks. You either got 2 marks for having all 3 answers, or you didn't. That's just the way that one was graded. I didn't make that up. You got 1 point here, and you got 2 points there. And that's it. Yes?
What would be the reason for getting only like one of those answers?
Your window was bad. Or you didn't zoom in close enough to see that it had several intersections.
So when we went to intersect,
Second trace intersect.
they grabbed a random one?
Well, the problem is that 2 of them are so close to each other that just getting quote-unquote close to it could have been close to either one of them, and it wouldn't have showed you that there was a different answer there. Now, again, I've never seen a graph like that before, ever. This is the first time I've ever seen this question. You guys were the first class to ever do this question. Yeah, well, I don't know. I might put it on a test in the future. Who knows? But the point is, when the lines laid on top of each other, I immediately was like, well, that's no good. So I tried to play with the window, and I couldn't separate them well enough. So I thought, okay, well, let's see what happens when it's equal to 0 then. And I'll look for where it crosses the x-axis. Okay? Problem solvers, guys. Now, I don't really use the zoom feature. I don't like it. But that's just me. So, nobody got marks for this? Nobody. And here's why. Rate of growth. Oh, you got some marks? That's good. Rate of growth. What I tell you rate means? Derivative. Find the total amount of time when the rate of growth of B, the slope of B, is greater than the slope of A. You have to find the 2 derivatives and then figure out where one is bigger than the other. Okay? So, first things first, we're talking about B is being greater than A, but I went ahead and found them in the order of HA prime. Okay. The derivative of sine is cosine, but this is going to require you to use a chain rule. But since it's a graphing calculator style question, I'll just do this. And then we'll say, oh, times 2, because that's the chain rule. Derivative of 9t is 9. Derivative of 27 is 0. There. There's one of the 2 rates of change. The other rate of change is the height of B. Well, B is linear. So its derivative is literally its slope, 8. So we were just trying to figure out where h prime of B was greater than h prime of A. You were trying to do this. Oops. I said B and then wrote A for some reason. That's what you're trying to do. So you write, I'm going to put this 2 in front just because it's really bothering me that it's in the back like that. 2 cosine of 2t plus 6 plus 9. Trying to figure out where it's greater than 8. That's what we're trying to figure out. Cool? All right. What's that? Crap. You're right. I have them backwards. Sorry. This is A. This is B. There we go. I'll just switch the symbol so I don't have to erase everything I wrote. Sorry about that. This is B. Good catch. That would have messed us all up. All right. Time for the graphing calculator. On y equals. Clear that crapola out. Now, check this out. This is a cosine wave with an amplitude of 2. A cosine wave with an amplitude of 2, midline of 9. So it's going to go from 7 to 11. So window, we said it's going to go from 7 to 11, so let's just take it to 15. Why not? Ta-da. Now, you could have done this algebraically, to be honest with you, because if you subtract 9, that gets you a -1, and you divide by 2, that gets you a -1/2. That's actually one of our special triangles that we could have done. I didn't, because it's a calculator question. What I did was I realized that this is a pattern, and that each time that red line, which is 8, is above the blue stuff. So blue stuff is under red stuff 3 different times, and they're all the same size. So I found the distance between intersection 1 and 2, and then I just tripled that answer. Second trace intersect, yes, yes, scroll. Maybe scrolling takes longer than anything else. There's one intersection at about 1.19. Tell you what, I'll go out to like 4 decimals because why not? And let's find the second intersection. Second trace 5, yes, yes, scroll. And if I go out to 4 decimals, that's 236 if I go out to 4 decimals. So 2.236. Now what I did was I found the distance between those 2 times. I just subtracted. So the it was 236, correct? Not 336? Was it 236? Okay. All done? Cool. Thank you. Alrighty, I'll see you later. I just subtracted. 2.236 minus 1.1888 is this number. And then I just said 3 times that because if you noticed that wave, its pattern happened 3 times on the graph. So I just tripled that distance of time, and I got 3.142. 3.14. Wow, that number sounds oddly familiar, doesn't it? Literally pi, if we had done it by hand. If we had done it by hand, we would have gotten that the distance, we would have gotten pi over 3 and then tripled it. So pi. But there you go. Okay. Now, this last one on this page was extra credit, and this one was from the extra things that I told you to do in the textbook. I don't know if anybody noticed the very last question was binomial expansion stuff. Did anybody actually do it? A couple of you? Okay. Ha! That's why I put it there. Anytime I put extra stuff like that, it's because it's a skill that we haven't talked about in a while, but it's on your test. But it was extra credit, okay?
Did you see me struggle?
Nope.
With this? It was so funny.
F prime of x, because it's asking for us to find its expansion. F prime of x requires you to use the chain rule. First, bring the 7 down to the front. Don't touch the inside. Becomes a 6 now. Now you multiply by the derivative of the inside. There you go. So 14x, x squared plus 6, x squared plus 3 to the 6th. I believe that was worth 2 points. So if you got plus 2, it's because you found a good derivative. A number of you got plus 2. Okay, now it's time to do a binomial expansion on that thing. 14x does not expand. It sits in front of the expansion. This is what expands. So our f prime of x is a 14x, then a 6 choose, I don't know. I have an x squared raised to the 6 minus the number I don't know, and then a 3 raised to that number I don't know. We have to play the exponent game. Power to a power makes you multiply. So you have 14x to the first, by the way. 6 choose r. I'm going to put my constants in the front. 3 to the r, x to the, distribute the 2, 12 minus 2r. These x's are multiplied. And when you multiply numbers with the same base, you add the exponents. So we're dealing with an exponent of 13 minus 2r. X to the 13 minus 2r. Cool with that? That's what we're dealing with. Now I needed x to the 5th. So I needed 13 minus 2r to be equal to 5. That makes r 4. 13 minus 8. So r is 4. It says find the term that has x to the fifth on it in the derivative expansion. So what we're going to say is t sub, remember it's t sub r plus 1? So it's the fifth term. You didn't have to actually know it was the fifth term, but it is. We have a 14 on the front. This x, remember we combined it with this x to get this 13 minus 2r. I have a 6 choose 4, whatever that number is. I have a 3 to the fourth, which is 81. X to the fifth. 14 times math, prob, NCR. 6 choose 4 times 3 raised to the fourth, in case you don't know what it is. And you get that number, 17,010, x to the fifth. And there it is. Okay? 294. Are you the one that forgot the 3 to the fourth?
I was the one that forgot the n choose 4.
Somebody had some good math, but then forgot the 3 to the fourth power. I don't know who that was. It's okay. And I do need to snap, crackle, pop because shortened period today. Don't worry, the video will be on YouTube before I leave. Okay, that's the entire calculator portion. No longer need the calculator. Boop, here we go. This one straight up and down says find the derivative. Guys, there's a 1/3 here. That 1/3 doesn't go away. It comes along for the ride. The derivative of x to the third requires you to bring a 3 down to the front, though, and subtract 1 from its exponent. The derivative here requires you to bring the 2 down to the front, subtract 1 from its exponent, and the derivative of negative 15x is just negative 15. But 1/3 of 3 is 1. There you go. X squared plus 2x minus 15. Horizontal tangents. What does that mean? What does a horizontal tangent have to do with derivative? Slope is 0, which means you needed to set the derivative equal to 0. This factors to x minus 5, plus 5 times x minus 3. That means x is negative 5 and x is 3. But if you paid close attention to the directions, it says find the values of a and b specifically with a less than b. So you had to say a equals negative 5, b equals 3 to get full credit. Ta-da! Okay, next. 2 marks. Find the derivative of cosine 2x. Why do you think it's worth 2 marks and not just 1? Because there's 2 skills. Chain rule is the second skill. Derivative of cosine is negative sine. The chain rule says times the derivative of the inside. It's 2 skills. That's why it's 2 marks. Derivative of cosine is negative sine. Chain rule says times the derivative of the inside. Done. G prime. The derivative of every natural log is 1 over argument. Why is it worth 2 marks? Chain rule times the derivative of the argument. 1 over argument times derivative of the argument. So it's just 3 over 3x minus 5. I wonder why we had to find f prime and g prime. Is it because the derivative is just you multiplying the 2 derivatives? No. I told you when you're finding the derivative of function times function, you have to use the product rule. F prime g plus f g prime, instead of saying u's and v's, because it gave them to us in terms of f and g. F prime g plus f g prime. You didn't have to do any cleaning. You just leave it like that. It was only worth 2 marks. And it's funny that number 5 would be right after number 4, because number 4 was a product rule question. Hey, look at number 5. Function divided by function. Quotient rule. U prime v minus uv prime all over v squared. U is 6x. V is cosine x. U prime is 6. V prime is negative sine x. All right. H prime of x. Notice I'm not messing around with the 0 right now. I'll plug in 0 later. Okay. By the way, those of you that just did 6 over the derivative of cosine x, how did you think you were getting 6 marks for that? Please think. 6 marks? No. Okay. U prime v is 6 cos x minus, because there's a minus there, u v prime. Hey, v prime is negative. So minus this negative product, plus 6x sine x over v squared cosine x. So cosine squared x. Great. There is your derivative. Time to evaluate at 0. That gives me 6 cosine 0 plus 6 times 0 sine 0 over the cosine of 0 quantity squared. Well, guess what 6 times 0 times sine of 0 is? It's 0. So at that point, all you need to know is that cosine of 0 is 1. Ta-da! Yes, it does. 6 times 1 does not equal 1. It equals 6.
I got that now.
It's okay. Proximo. Number 6. First time I've ever done number 6. I thought it was a very interesting question. Notice that your first curve is a product. It's a linear times an exponential. Your second curve is not a curve at all. It's linear because k is a number. So 5 times e to the k is a number. This is literally a number times x. It's linear. And I'm making a big deal about that because it says tangent to the curve. Oh, derivatives at x equals 1 is parallel to this one's tangent line, which means their slopes are equal, which means at x equals 1, their derivatives are equal. Time to find our derivatives. I was a little peeved that they did it like this, so on my paper I called it y1, y2, just so I could delineate them for myself. And I said, okay, for y1, I'm working with a product rule where u is 2x minus 1 and v is e to the kx. Well, since u is linear, u prime is just its slope. The derivative of any exponential in our IB course is rewrite the exponential times the derivative of its exponent. Ta-da! So this is a weird thing to say. y1 prime, the derivative of y1, is u prime v 2e kx plus u v prime. 2x minus 1 ke kx. But we're doing this at x equals 1, aren't we? So at x equals 1, what you're going to get is 2e to the k plus 2 times 1 is 2. 2 minus 1 is 1. That goes away, and this x is just a 1, k-e-k. And we're setting it equal to y2's derivative, y2 prime. Oh, that's right. y2 is linear. Its derivative is just its slope. I don't know if you got this, but ek can be factored out. And I'm going to factor it to the back. That way I can see that 2 plus k is 5. So k is 3. That's a neat question. I think that the kx threw some people off, where they thought they were dealing with an exponential of some sort, but you're not. This 5ekx, you had to realize that was linear, not exponential. Neat question. A few of you got it. I think like 3 people. Now this one went catastrophically horrible because everybody forgot their logarithm rules. Hey guys. This point says that the x value is a and the y value is 0. So 0 equals the ln of a squared minus 16. For those of you that did a lot of algebra instead of just understanding your graphs, what cancels natural log? E. Ah, yes. And what is e to the 0? It's 1. Yeah. And here we add 16 to both sides, right? Was that you that did that?
Yes, I know.
Okay.
I added 16 to 1 and got 15.
And you can clearly see that we are to the right of the x or the y-axis, so we can't have a negative answer for a. It is just the square root of 17. Yeah. Now, hey, look, gradient of this L. I wonder what we're going to have to do. I'll wait for somebody to say the magic word. Derivative. Yeah, we're going to have to find f prime of x because you see line L is tangent to f of x. So we need to find f prime of x. Okay, here we go. The derivative of every natural log is 1 over its argument times the derivative of its argument. And we were specifically told that that slope gradient is 1/3. So 2x over x squared minus 16 equals 1/3. You guys know how to solve proportions? How? Cross multiply, yeah. So what that's going to give me is x squared minus 16 equals 6x. I'm going to subtract 6x from both sides so that I can factor this quadratic. And since we know that x is greater than 4, only one of our two results matters, and that's x equals positive 8. That is it. They're not complicated. When you're under pressure, you panic. They're not complicated. 6 is the one with the EKX is a little bit of an interesting question because it looks more complex than it is.
I didn't.
Mm-hmm.
I missed one. Oh, it's because I didn't know that it was linear. I didn't think about that.
You didn't recognize it as linear?
Yeah.
Yeah. It's a strangely written question with the EKXs. I know, that's weird. But that's why I picked it. I'm going to be honest with you. And it's not even easy. I picked the ones that make you uncomfortable for a reason. Because when you take the IB exam, you're going to be very uncomfortable. You have to get used to it. I don't know. I don't know if they do or don't. I don't know. All I know is that the best way to learn IB is to do IB, and that's why I keep telling you guys to go on Google and just look up IB questions and just practice them. Because I tried to give you every question that wasn't on my test or retake, which means if you go online and you start practicing, there's a good chance you're going to accidentally practice some of my test questions. Someone's at the door. Like, Lewis. Not Lewis. Chris. Lewis. Weird. I don't know why I did that. That's your brother's name. I know. But this one. You did really well in that one, yeah? Yeah. Did you happen to see that one somewhere? Yeah. How about that? It's almost like studying the way I tell you helps. Okay. Hold on one second. Papa Squat. Let me do this, and then I'll take care of it. Okay? Last one. Find the first four derivatives. Holy crap. The number of you that thought that f of x was the first derivative. So many of you went straight to f double prime. Like 3-4 people did that. I don't know. Really weird. Here's what's up. F of x can be thought of as being x to the negative 1. First derivative. Bring the negative sign down. Subtract 1 from the exponent. You use radicals for some reason. Bring down the negative 2, multiply it to the negative 1. Subtract 1 from the exponent. Triple prime. Bring down the negative 3, multiply it to the 2. Subtract 1 from the exponent. And lastly, bring down the negative 4, multiply it to the negative 6. Subtract 1 from the exponent. Now, I don't like how they sit, so I am going to write them as fractions, but that's just a me thing. You didn't have to. Okay, there are 3 different things going on here for this expression. Very first one that we would hope that you noticed is that it's switching between positive and negative. You see that? There you go. Negative 1 to the n power. So when it's the first derivative, you get negative 1 to the first. When it's the second derivative, you get negative 1 squared, which is positive 1. When it's the third derivative, you get negative 1 to the third, which is negative. See how that works? Okay. The next easiest thing that we would hope you see is that on the first derivative, power 2, second derivative, power 3, third derivative, power 4. Literally, one more than the derivative type. And the quote-unquote challenging part, the harder part. 1, 2, 6, 24. Micah, what do we call those? Exclamation point account. Factorials. This is 4 factorial, 3 factorial, 2 factorial. Didn't you notice how you were bringing the number down and multiplying it to the one before it every single time?
Yes, I just didn't know how to write it. I tried to use geometric sequences.
There it is. It's worth 3 points because 1, 2, 3 marks. And that is your whole test.